Let's talk about the LeetCode number 721, account merge. For this question, it gives us a list of list string accounts and let us to return the merge result. So what's the merge result? Let's take a look at the example. We look at the example one, right? It has a name. The first, in every list string, the first element will be a name, and then there will have a lot of emails. We know if this is John, right? If those people have the same name, they may still belong to different people. But if for this name, they have the same email address, then we know this John and should belong, and the email belong to the same people. So we should merge this account and this account. For this John, we didn't find a John Bravado the same as those kind of email address. So it is a separate result. So this will be the merge result. Because it has this one in common. And so it will be merged to this kind of result. And you see that these emails should be in sorted order, but these names, they can be in any order. So for this question, what we think about is that we iterate every list, every account, right? And for every account, we try to have some kind of way to connect this email and this email, right? And also in this account, we can have some way to count this one or put that into one set, right? Then if there is some kind of email address that is the same, we'll put those kind of email into one set. So one kind of data structure we can think about is use something called a union find, or we call disjoint set. So we know for disjoint set is that for this kind of, we can begin to write code for the disjoint set or union find. We write a class called union find. And we have a map string variables and union find others material hash map. And for this kind of data structure, it has two kind of method. One is called a union. And we're going to have another method called a find. And for this map, it's going to store for every element, right? Element its parents use this kind of map to store its top parents. For example, if at the beginning we have a string A, its parent will be pointing to itself. And if there is some kind of for example, A and B, right? And we find that A does not equal to B, that its parent does not equal. And if we want to union A and B, we'll let A's parent point to B's parents. So So that will be what the union find, so that the AB will be in the same data set. And the find will find its topmost parents. That is, we find A and find B. So know that it's a topmost father, or topmost father is B, and B is topmost father is B. So that means if we find A equals find B, means this A and B belong to the same set, or we say they are connected. So for the union function, we can write this like string fa equals find A string of A B equals find B, right? So I say if fa dot A, if it doesn't equals, then we need to connect them. That is, we want to if they already equals, then we don't need to do anything, right? So we don't need to, because they belong to the same set. If it doesn't equal fa B, right? If it doesn't equal, what we are going to do is that we'll have a father put fa and fa B, right? Let A's father pointing to B's father. So this is what the union need to do. And for find is that we say if x equals fathers get x, that means x and its parents the same. Then just return x, right? And we'll have a string. Otherwise, we are going to use the string fa.x equals find fathers get x. And we are going to use fathers put x fa.x and return fa.x. Here we did some recursion call that is when we trying to find its father, right? And we every time we find its father, we are going to put x and its father to be fax, right? Because here there is some kind of recursion code, right? So here it is recursively to have the path compaction for the find. So averagely for the operation of union and find, it is close to be O1 time complexity because the time the path compaction here actually it is O log star or log star in something like that. It is pretty much constant for find the union operations. So these are two functions, union find function we need to write before we do this question. And the first thing we want to write the main function is that we need to have the union find function, help function, right? Have this new union find. And mm, we need to do initialization so that we iterate every account and set all of the account, the father to be itself. So we'll say for list account in accounts, right? We know from the index one, it will be the email address. So let's say for int I equals 1, I smaller than account of size I plus plus initialize that string email equals account with one. So the first thing is that we have UF values put in back. This will be the initial thing. And the next step is that for every account, we from the index 2, right? We union those emails to the index 1. So let's say for actually let me copy this code. And what we need is that for I equals 2, right? And we'll have union. And this one will be account that have the string we call first email equals account with 1, right? So it's just a union first email. So after these kind of operations, we'll have this one be union, this be union, and if this size does not have 2, right? Then we do nothing for this one. Also do nothing for this. So the second step. And what we need is that we need to create a map and to store the parent's email and all of the email which belong to the same connected set. So what we need is that we need to have a map string list of string, right? Or map. It's a new hash map. And we also need to iterate for each account still for this string account in accounts, right? Now we are trying to iterate from the first one. I was one. I summary account size. Let's press we'll say email string parent email equals email find account. Let's put this string email equals account fit right. So it's a parent email. We call father email or be find email, right? And here we'll say if this map we'll have the father email that is a top, right? Top parents for the parent, right? Top parents for this email. So we'll say if we'll put this one as key, right? And all of the email which have these parents will put it into a list. So we'll say map compute if absent p email it goes to new array list. Mm. Mm. New let's have it to be set so that it will not have duplicates. And also the result want this kind of email to be solid. So we can use the true set as it is set. It's solid, then add email, right? Mm. Mm. Actually, we know for every emails belong to the same account, they should have the same parent email. So actually, this one we just need to calculate once. We don't need to calculate every time. So we can put here P parent email equals UF9 account with one, right? We don't need to calculate this one multiple times. And also, we need to have a map which have the key will be the parent email, and the value will be the name. So we can have string. We call it email to name, right? New hash. Yeah. Let's say string. String. It's name equals your account. It's there, right? So we can also have email to name, but and to email, and then right here. And the last thing is that we are getting from this map and email to name to compose this result. So we just iterate the keys from the email to name, right? And also this key will be the parent email, and we get its name as the first one. So the how many results in the result list will be the numbers of the keyword pairs in these two maps. We can have a list string result with new array list, right? And we'll say for string key in map. We have a list string. We have a account, right? With new array list. And for account, first thing is that it need to add the email to name get here, right? And also we need to have a for string email in map get key, right? This is already sorted. We'll have account add email. So then we just return result. Others. 37. Cannot find the symbol UF data. No, should just say union. And 57. Key set. 61. This should be ACCT, right? And also our result should add this account. Yeah. Let's take some other test cases. Okay, so for this question, we say those kind of union and find they are O1 operations. So we'll say if totally there are this is the length and the account I length that is for example, we have this will be n and this is m, right? So we'll say it is m multiplied by n, right? So the total account operations unit of find operation. So so if a total emails have n, that is O(n) time complexity, right? The space complexity is that what we use here for is kind of list or map, right? They are all linear data structure, so that space complexity is also O(n).